All right, so welcome back. In this module, what we are going to use is a very ingenious invention to ask the everlasting question: how long will I live? We've been asking this question for eons, generations, and except for the extreme, obvious, someone about to commit suicide or something, we really don't know the answer to this question. But it seems to be of concern, and we always see, actually once a year, we actually see this in the press, a huge number of articles about how long we will live. So, for example, now most babies born today may live past 100. Here's something that appeared in 2009 as a result of an article that appeared in Lancet. But the American comedian George Burns had an answer to that. George Burns, he lived to be 100, but he says if you live to be 100, you've got it made, because very few people die past that age. But on a more serious note, how can they make such a statement? Most babies born today may live past 100. I mean, they're predicting 100 years into the future. Is there any validity to a prediction like this? And the answer, first of all, is we cannot answer the question, how long will I live? But what we can do is we can answer a question which is, how long do we live? So we can make a statement about a group as opposed to an individual. And that's what we're going to try and answer now. How do we make such a statement? Now, the Romans built on this. They observed some constancies, and they were able to build on this. For example, you need to be able to answer this question if you want to buy annuities. If you want to buy insurance, how do you answer these questions? That's what you can answer, is the group behavior. And a large part of this was based on sort of guesswork. Actually, a lot of insurance companies went broke and everything, until Halley came along, and he showed us about 300 years ago how to calculate what is called the life table. And we've been doing it that way for the last 300 years. Okay? So what the life table does is it tells us how long people live on average. But it's a very, very special way of telling us that, and this is what we're going to try and understand. So this is useful, as I said, for insurance companies, for annuities, for planning Social Security, how many people will be cashing in on Social Security in 30, 40, 50 years' time, etc. And how do we build up savings and so on to accommodate this. The way it's done is very, very cleverly done. What it does is it converts what we call cross-sectional information into longitudinal cohort information. So cross-sectional is, we like take a cross-section of something. So it's like taking a snapshot. We take a picture. We take a picture that may be of a year or two duration, and then the longitudinal one is project that like a film, like a movie, into the future. So the idea is we would love to track a population for the next 100 years or so, but we can't afford to do that. We don't have the time, etc. So what we do is we take a snapshot today. Technically, we say we've got cross-sectional information, and what we're really interested in answering this question is longitudinal or cohort information. So let's zero in on this, and let's think about the average lifespan, or how long do we live. So I'm going to do it by example. Suppose we've got a population of 10 people. Here is their life experience. So here's the individual survival for each of these 10 people. The first one died after 1 unit, the second after 2 units, and then the next after 10 units, and then the next after 20, and so on, and the last then 60, 70, 80. The last one lasted for 80 units of time. So what is the average of these? Let's look at the mean. So what do we do for the mean is we take their sum, which is 373, and divide by 10. So this is one way of defining the average lifespan, is to look at the mean. So the mean lifespan is 37.3. What I want to do is I want to put some physical meaning into this and try a little demonstration for you in interpreting this calculation. Here we have, what I've done is here we have some sticks. I've cut 10 of them. Each stick represents one person, and the length of the stick is how long that person survived. So for example, this one is 80, and because the longest was 80, and then there's the 70, person who survived 70, all the way down to the 2 and the 1. That little one there is person who survived, little baby, only survived 1 unit of time. Now, I want the average survival. So the mean average survival should be the sum of all these lengths divided by 10. So one way to do this is I can lay these sticks out. So for example, there's the 80. So that's 80 units. Then the next one, I put it in front. And so together they're 150 units. And then the next one, which was 6, brings it up to 210 units, and so on. I string them all out like this, make sure I have all 10 of them, and then what I can do is look at the final length here, and here's the little one, and then divide that by 10, and I've got 363 divided by 10, and so I've got the average is 36.3. Alternatively, what I could do is rearrange these sticks in a different direction. I can put the 80 at the bottom of the pile like this, and then I can, on top of that, put the 70, and then on top of that, put the 60, and on top of that, the 50, and then the 45, and then the 35, and so on. And now, what I've got the same sticks, so their total length should be the same, but I've got them in a different configuration. So nothing's changed except the configuration. Let's leave the sticks and actually draw what happens before we explain anything further. So here is an idealization of those sticks. So here's at the bottom we have the stick that lasted 80 units. At the bottom is 80, the next one up is 70 units, and so on. So here they are, all 10 of them, and as we saw, if we put them lengthwise, it adds up to 373. But now, what I want to do is I want to stack them like we did, and here is the idealization. If I want to calculate the mean, let's go back to our slide, and we said the mean was the 373 divided by 10. Now, another way of thinking about this is let's do the division before the summation. So instead of doing the summation first, do the division before the summation. So if you divide this by 10, it's like multiplying it by 0.1. Then you have to add 2 times 0.1, then 10 times 0.1, 20 times 0.1, 35 times 0.1, etc. And that should give you 37.3. That's just simple arithmetic. We're just changing the order of the addition and the division. Okay, so now remember this. This is how we calculate the mean. All right, so keep that in your head. Let's go back to our sticks. So this is what we want to achieve. So now what we should do is, look what happens if we make the width of the stick 0.1. If we make the width of the stick 0.1, what is this quantity here? 80 times 0.1. 80 times 0.1 is just the area in this rectangle. What about 70 times 0.1? 70 times 0.1 is the area under this rectangle, because I've made the width of the rectangle 0.1. 60 times 0.1 is the area under this rectangle, and so on. The 50 is the area under this rectangle, and then we have the 45, the 35, the 20, and so on. So that if we look at this curve, think of this curve here, which starts off at 1, because we had 10 sticks, each of width 0.1. If we look at this curve here and follow it all the way down, what is the mean? The mean is just the area under that curve. So the mean is just the area under the curve. That curve is called the survival curve or the life table. Changing our x to have them equispaced so that they look more pretty, and changing the vertical scale to be percentages. So instead of 1, we'll have 100%, 90%, 80%, etc. Then we can make the statement that the area is equal to the average survival. So the area under the survival curve is equal to the average survival. This is a very, very useful device, this survival curve or this life table. 1, we get that the area is equal to the average survival. 2, we can read off other quantities from this curve. For example, if we go up to 50%, that is the median survival. So the median survival is going to be anywhere along here, which translates to 35 to 45. It's a flat spot, so any number between 35 and 45 will satisfy the definition of the median. Remember the definition of the median: 50% above, 50% below. Then at least 50% above, at least 50% below. Then any number between 35 and 45 will satisfy them. By convention, we can take the midpoint, and the midpoint is 40. So the median of these numbers is 40. Okay, and that fits in well with here. So we read it off the survival curve as a median. Now, the average is very often used as a single number summary to tell us how well this group is doing. So for example, if this were a survival curve for a nation, this might be a national average. Another summary that we can use is the under 5 mortality, and that, the way we get that is we look at age 5. So here's age 5, and we look up and we see that 80% survive to age 5. In other words, 20% do not. So the under 5 mortality can be read off this curve, and in this example, it's 20%. So that's the under 5 mortality. Very often you'll find this in the literature to summarize the health experience for a country, to see how children survive in a country. Another one is the adult survival. The adult mortality or adult survival is asking the question, what happens between the ages of 15 and 60? So at 15, there are 70 people who make 15, and survive almost to 60 is 30%. So the adult mortality is defined as 70 minus 30, that's how many die between 15 and 60, and divide by the 70 that originally were there, and that gives us 57%. So with this set of data, the adult mortality is 57%. So those were 3 ways of gleaning information from this survival curve. Summary numbers associated with this survival curve. Now, what happens if instead of 10 people, we have 20 people? So suppose we got this extra data, and we got a new person at 2, 7, 12, 15, and so on. Then you can see what happens. Now we have 20 of these people, so the step sizes become half of what they were before. So the survival curve now looks something like this. And you can imagine that the more and more and more people we get, the smoother and smoother this survival curve becomes, and we'll end up with something like that. So for example, here are 3 survival curves, and they all refer to the USA, and the bottom one is the survival curve from 1900 to 1902. The middle one is the middle of the century, so it refers to like 1949 to 1951, and the top one refers to 2006. So here we go across the 20th century, and you can see what our survival experience, what has happened to our survival experience. The first thing we notice is that this is disappearing. This huge infant mortality between the ages of 0 and 1 is slowly disappearing. So here it was at the turn of the century, there it was in the middle of the century, now it's almost flat. It's almost gone away. What that has done is it sort of brought this curve up, so that when we look at the average, survival, remember the average is the area under the curve. So if we look at the area under the curve, in 50 years we can see how much we've added to the average. We've added a tremendous amount to the average survival in the first half of the century. In the second half of the century, we added even some more, but not as much as we did in the first half of the century. Okay, so that's the average survival. Another way of looking at that is to look at the median. So here's the median, and the median, so this is the 50%, is to get the median. And as we cut across, this is me with fancy PowerPoint effects. As we cut across, we see what's happening to the median. So the median at the beginning of the century was at about 60. It went up in the middle of the century, went up to about 74 or so, and then it's at about 82, 83. So we can see this progressive improvement as summarized by the median. Now the question is, how did we construct these curves? I haven't told you how we constructed them. I just showed them to you. I didn't construct them. The National Center for Health Statistics constructed them. But how were they constructed? You see, they go down to 100 years. So did we wait 100 years? We could afford to wait 100 years between 1900 and 1902 because we are beyond 100 years. But we're only 50 years away from this cohort, and we're only about 6 years away from this cohort. So did we wait and watch until everybody died? And the answer is no, of course not, because most of these people, at least half of these people, are still alive, and just about all these people are still alive. So how were these curves constructed? Okay, so I'll leave you time to think about your understanding of these curves, and we'll come back and concentrate on how they were constructed.